Hi, everyone. My name is Sai with the Tasker Center, and it is my pleasure today to introduce our keynote speaker. He has a wealth of experience building assistive products for blind and low vision communities using augmented reality, robotics. 25 years as a product executive leader, most recently at Microsoft Research. And he continues his work now as the CEO of Glidance. So please help me welcome true champion in the space, Mr. Amos Miller.
Well, thank you. Thanks everyone. Let me just sit. Hey, Annette. Very good, thank you. I need a bit of sound from everyone. Say hello. Hello. There we go. Now I can situate myself. Thank you. I'm just going to pull up some notes here. And we'll get started. Anat and Kunal and the whole Tasker Center, thank you so much for having me here this morning. It's a real honor to be here. I'm Amos Miller, and I'm here with my co-founder Kyle. Kyle, where are you? Over here. Kyle is going to help me drive the slides here, and feel free to contribute. And before we get started, and you have an exciting day ahead of you, before we get started, I'd like to ask you to all close your eyes just for a moment. And don't be afraid, nothing is going to happen. The slide is dark, you're not missing anything on the screen. And when I snap my fingers, you can open your eyes again. But what if I never snap? You had sight for most of your life. You saw the smile of your loved one, the colors of spring. You could walk. You could weave through crowds, duck under branches. And now you feel that chill of uncertainty, and you wonder if you'd ever feel independent again. And that's the harsh reality for 300 million blind people today. You can open your eyes. 300 million blind people in the world. The great majority lose their sight later in life. And the only way that they can get back their independence is to learn how to use a white cane or a guide dog. But today it can take 5 years and $100,000 for a dog. And to get one person trained, that means that it is not scalable. Only 2% of these 300 million people actually have the ability to get around. It's higher in the Western world and less in other countries. 98% of blind people don't leave home independently. And I want to discuss how we can work together to solve this problem, to address this issue, and to, in many ways, disrupt an age-old industry with advancements in AI, robotics, and data. So, as I said in the beginning, I'm Amos Miller. I'm the founder and CEO of Glidance. And we are leading the field of autonomous wayfinding in pedestrian spaces to empower the billions of people on this planet who need a helping hand to get around. That's our goal. My background is in computer science, engineering, artificial intelligence, robotics. I spent many years at Microsoft, as Anat and Sai talked about, and I'm also blind. I lost my sight in my early 20s as a result of a genetic eye condition. And when I was around 7 years old, I saw a computer for the first time. I was still sighted, and I remember until today, I remember that moment, seeing that green cursor tick, tick, tick on the screen. I was mesmerized. At the time, I still have sight. Not quite enough to have me on your soccer team. I would not recommend that. But I still had some sight. I took computer science in college, and honestly, I'm not entirely sure how I survived it. I still have nightmares wandering the halls of the campus that I studied at. I was a pretty strong student, but because I was rapidly losing my sight during that time, I ended up choosing classes not based on what I wanted to study, but based on the routes I was familiar with. There was a period of time that became so hard that I stopped going to classes. You can see a good dip on my transcript with my grades during that time. I did eventually go to learn how to use a white cane. And by the time I finished college, I actually was lucky enough to receive a guide dog. And that made a huge, huge difference in my life. Now think about it. I am studying at the forefront of technology in one of the leading technology institutions in the world. We were working on neural networks, which is the foundation for AI. That was the beginning of the 90s. Computer vision, navigation, and I am struggling to get around. And that's when I started to think there has to be another way. There has to be another way to this. So when I moved to London with my wife back in the late 90s, I worked in a range of technology companies. It was a dot-com era, high demand for software engineers. But every time I changed company, I had to learn my new routes. That meant that my wife and I would go on evenings and weekends, back and forth, learning those routes. And slowly I would build the confidence. And again, that question came up. I'm working with the best technology companies in the world, at the frontier of technology. We were literally building the foundation of the internet and mobile technology. Yet getting around is still hard, slow, stressful. And one morning when I took my daughter to kindergarten, I laughed to myself. Who's guiding who here? I mean, she's 3 years old. We're walking along. We are landing rovers on Mars. We have supercomputers in our pockets. How do we tap into that human ingenuity to make a material difference on our ability to get around? Not on the edges, a real difference. At the time, I was already working at Microsoft. I joined Microsoft in the UK. I was also the chairman of Guide Dogs for the Blind in the UK. And Guide Dogs for the Blind, just for those of you who are not familiar with, in the UK, they are the largest non-profit in the UK, pretty much, and the premier organization for independent mobility for the blind worldwide, a very recognized brand. But in the UK, there are almost 1 million people with significant sight loss or total blindness, and only 4,000 guide dogs. The biggest school in the world is serving 4,000 people. So I posed the question to the board. I think we have a scalability problem, right? How can technology change the game here? So what we did, because I was working at Microsoft, we formed a partnership with Microsoft, bring the technology people and the mobility people in a room and say, how do we address this scalability problem? That led to a significant investment by Satya Nadella. He wasn't the chief executive at the time, but he became one very quickly, thank goodness. And we researched the topic, and ultimately that led to the development of Soundscape. Soundscape is, thank you. Soundscape is, in fact, one of the breakthroughs, in my opinion, in products for orientation and wayfinding for blind people, and is used by a wide range of people today. And here's the idea. Basically, the way that Soundscape works, you'll all know that for a blind person to move in space and to make confident navigation decisions, they need to have good orientation. And they need to know what's around them. They need to have a sense of place so that they can walk confidently. So when you look around, for example, and you see the house in the distance and you see the path, you have your orientation, you can make your navigation decision. You can decide where you know where you are, which direction to go. And that's what Soundscape was doing by producing that image in the mind's eye using spatial sound, using audio. So if you'd walk along and you'd hear, if Starbucks is coming up on your right, you'd hear the word Starbucks over there on your right. Okay, so you have that sense of orientation. Sound in 3D around the person is a very powerful capability. You just, the way that it worked is that it used GPS. It uses GPS for your location, and it pulls data from OpenStreetMaps, which some of you might be familiar with. And we actually worked at the time with Anat and the team here to figure out and understand how the critical data, such as the location of crosswalks, the mere existence of sidewalks along a road, that's not a given. Often the sidewalk, it might be there, but not be passable, or have some blockages, or not be there at all. And how do we start to understand and enable a person to get that information so that they can improve their orientation and make their navigation decisions? And honestly, the Achilles heel of the whole project was the poor quality of the data. You had great orientation with Soundscape, but you couldn't make solid navigation decisions because you didn't get the essential information. Soundscape did become one of the leading navigation products for the blind, used by the blind community. I would speak in conferences. I received awards. I mean, this is huge, and it's still being used. But deep inside, I still felt that we failed. We failed because, despite all of that success, we were not getting more people out and about. We helped the people who are already out and about go further, which is important, right? It's really empowering, and people feel a huge improvement in their quality of life. But we were not getting more people out. We were not changing the world. So one day, sitting at the airport, I'm waiting for the assistant to come and get me and force me to sit in the wheelchair, even though I don't want to sit in the wheelchair. And we all fight about it, and I feel down and frustrated and angry. It's 2022 now. Computers are writing poems. And I'm still sitting here waiting for somebody to guide me to my gate. Soundscape is not going to help me with that. What's going on? So what's going to do that? And that's when I realized that it doesn't matter how smart the AI is. If it can't communicate with me, it's not going to help me, or not in the way that is going to empower many other people. It's about how it communicates. Telling me to move left a bit, right a bit, that's not how we work. That's not how our brain works. I tried using directional audio. I tried haptics. The feedback loop is too slow, okay? For a 55-year-old woman who loses her sight and needs to continue with her life, get children to school, get to work, go shopping, none of these solutions are going to help. For her to walk confidently through a crowded space, commute to work, get to school, what she needs is a device that is physically connected to the ground and physically guides her, okay? By the next morning, I decided to put this to the test. How do we put it to the test? We get an RC car, remote control car. We put a broomstick on top. I get somebody to drive the car. I hold the stick, and I see if it works, okay? And that's what we did. No need to write a single line of code to do that, by the way, which is very empowering. And at that moment, I knew that we are onto something, okay? We are onto something. We don't know exactly what it is, but I tested it with a few other people. Something that is physically connected to and physically guides. This is going to be meaningful. So the obvious place to start is a robot guide dog, right? I thought that for about 30 seconds too. Because if you think about a robot guide dog and you start wondering, okay, I need to have this thing with me all day. How am I going to get this into my Uber? What about on the bus? Where do I put the wonderful thing? Sitting in the restaurant, where is it going to be? Is it going to fit under the table? What about on the flight? Can I walk with it onto the aircraft and stick it up in the sky, in the overhead compartment? What about battery life? I mean, I need a mobility aid for the whole day. I can't have it run out of battery after 20 minutes because that's the amount of batteries we can carry. What about the weight? What happens if it steps on someone's foot? 20 kilograms of a robot guide dog. And the cost of these devices are still way, way out of reach. So here we are again, building something that no blind person could ever afford or use in their daily life. So once those 30 seconds passed, and I reflected on my RC car and the broomstick, it all became clear. And that's how Glide was born. Okay, so Glide is the mobility aid that we are developing. And it's providing an alternative mobility aid to the cane or the guide dog. It's a light and versatile device, 2 wheels on the ground, the long handle, you hold the handle, you nudge the device forward, and you simply walk. It's not pulling you, the wheels are not motorized, you are pushing it forward at your own speed, in your own comfort, complete agency. And as you walk, the wheels steer the way, avoiding obstacles, keeping you on that safe path. You can say, hey, Glide, let's go to Starbucks, and Glide would look for a path and guide you there. It's very, very easy to use. And now I have a way for the AI and I to communicate. Okay? It can communicate with me through a physical experience. The physical experience that I have as an individual, the way that my brain works, it's a device that is affordable. It is viable. It is powered by our sensible wayfinding AI. We call it our spatial intelligence AI for effective navigation in complex and unstructured pedestrian spaces. It's very quick to learn, very easy to use, and designed from the ground up to be affordable. Thousands of people have tested our device already, and they tell us that this is as familiar as holding on to someone's hand. We'll soon have thousands, then tens and hundreds of thousands of these devices out there, where every step that a person makes unlocks independence, gives people their independence and livelihood back, but every step also builds that real-world experience for the AI to learn from, collecting data that is needed to finally unlock that generational promise of robots to better the lives of billions of people on the planet. And before I close, let's pause for a moment and just consider what this really means, okay? In 5, 6, 7 years' time, I believe that we will see many more blind people out and about, some using white canes and dogs, but many will be guided by some form of an intelligent guide. We will start to see governments and nonprofits starting to adapt to the scale, the sheer scale that these technologies will provide. They will realize that with the same resources, they can support 10 times, 100 times more people. And I would put it to you that in the next 10 years, everything is going to change. And why? These intelligent guides are going to be so powerful and affordable that almost every blind person will be able to get out of their home without hesitation. Think about it. In the US, there are over 7 million people with significant or total sight loss. Today, less than 200,000 are out and about. By 2035, all 7 million will be out and about. They will feel empowered to be out and about. And they will be, with all the other technologies that are coming about, they will be able to do a lot of the jobs that they want to do. participate in the activities that they want to participate in. It is a very exciting future. I think it is an inevitable future. And it's in a future that's posing interesting questions. How does government respond to this? How does, over the past 50 years, we made incredible progress with accessibility and the affordability, on policy, the American Disability Act, the UK Disability Discrimination Act. These policies ensure that governments and organizations invest in the accessibility of their services. But now we have to shift gears, move from disability as inclusion and compliance to look at the sense of belonging and agency. Take an airport, for example. Glide is not just a mobility aid that, what it is, it's actually an agentic wayfinding AI. It looks around, it pulls all the data that it can get, and it finds the way. It guides a blind person through the airport without the involvement of the airport. The AI agent can look up the maps just like people do, and then guide the user in the same that people navigate the airport. So what is the responsibility of the airport now? It's no longer about compliance, right? It's the opportunity to curate that experience so that every passenger feels a sense of agency, that they truly feel that sense of belonging in the space, that they are not just a fifth wheel. And what is the responsibility of municipalities, public transportation providers? How do they assure that not only the physical infrastructure is accessible, but the digital infrastructure, the data, the maps, the richness of the city, enabling citizens of all abilities to enjoy that sense of belonging and agency in these spaces? An agentic wayfinder will do its best. It will do its best to guide the individual in this environment, drawing on information that it can draw on. If Glide finds a path to guide me on, and the crosswalk on that path doesn't have an APS, I'm not going to be able to cross that road. If it guides me along a road or a route that doesn't have that sidewalk that we talked about earlier, I'm taking a dangerous option. If there's construction that's blocking that path today, we need to start addressing the question, how do we help the agent get the information it needs with quality and evergreen sidewalk data and pedestrian data spaces to be able to plan routes? And conversely, how do we use and work with these agents, these devices, to help maintain the evergreen nature of this data and information so that other people who come by can benefit from that as well? These are the enormous opportunities, because we'll have all these blind people and other people working with these devices in the physical world, and we can use that information to improve and make those spaces evergreen. And again, I want to restate the opportunity. Every blind person leave their home independently and without hesitation. That is the future we are working towards. The social benefits and economic benefits of that are incalculable. And the most interesting question in my mind is, will the technology actually erase some of these barriers that we experience today as a disabled person? And if so, what is the difference that remains? Am I still blind? It's the human experience. I would not be standing here today if I was sighted, because my life experience as a child who fell in love with technology at a very young age, who didn't play soccer, who had to struggle with sight loss during college, walked his daughter to the kindergarten. This is my humanity, and this is not going to change. Whatever AI technology I'm going to use, you wouldn't be here had you not have your life experience. It's your humanity, and that's not going to change whatever technology you use. And that what makes life worth living. So go get them, and thank you very much. We can take some questions. Yes, for sure. I don't know how much time we have left, so you want to give us
10 minutes.
About 10 minutes. So, yeah, questions on anything here are welcome. Kyle is here as well, on the technology or any of the topics we discussed.
I will start. Thank you. Thank you, first of all. That was both motivating but also very informative. I appreciate that. I'm wondering, some of the mentions you made of agentic AI imply that you have on board agents alongside with some of the statistical methods to assess what's in the environment, but also, go pull data in ways that are more variable. I'm wondering about your current experience with these agents and whether you see any complexities with having that data, sometimes not be verifiable on the fly in real-time situation.
Yeah, no, it's a great question, Anat, and it's not going to be all done in one day. I think that one of the investments that's going on significantly right now is in what people refer to as real-world models. And the importance of that is you have, so the way that that agentic wayfinding would work is that, like I said, it pulls the best data it can find. It makes a prediction of what would happen if you made a move in a certain direction. And then you move and you verify if that prediction is materialized or not. And that feedback loop that your sensory experience, and here we have two sensory experiences. One is a device, the other one is a human being that's going there. Yeah? You use that feedback loop to either improve that prediction or modify the data that it was based on. Yeah, and so what we are experiencing today is the VLMs, the visual language models that are being developed. All the big AI technology companies are investing hugely in VLMs. They are pretty good at answering directional questions. Like if I stood here and said, hey, guide me to the bathroom, it will look around and say, there is no bathroom here, but so we first need to get out of this room, so let's go to the door first. That we already have, okay? If it could draw on the map of this building, it could do even better and say, I actually think I know where the bathroom is because I went to the website and pulled the map. But then when I walk, it may prove to be incorrect, and then I have to decide why is it incorrect? Is this information that was wrong? Is it, do I need to go in a different directions? Maybe the path is blocked. So that's kind of, it's a redundancy system, right? It's a fusion of information system. I think that where the gap today is really in the middle between the VLM and, we are training semantic segmentation to map to understand what's a walkable space and what isn't. But that space in the middle that needs to decide, is this a good path to go down or not? Is this a route that's going to get me to my destination? That's where you need that tighter precision in the data and the information. And I see that where the opportunity is, the data that is being developed here, as well as feedback loops that you can get from agents that are out and about. And strengthening that layer. That's really what we're working on at Glidance, that ongoing training of that middle layer. Any other questions?
Hi, thanks so much. My name is Paolo. I work with Anat. Incredibly inspiring to hear this. I was wondering if you could paint a picture for us of what the pathway to widespread adoption is. What are the dependencies? What are the things that need to be unlocked? How long will it take? What is the public sector role in that? What are the private sector roles in it? Are there technology blockers that you have? How do we get to this vision that you painted where the 7 million people in America that aren't out and about yet can go out and do what they need to do every day without any barriers?
I can share some thoughts. I'm sure Kyle can as well, but in many ways, I don't think we quite know. I mean, it is a technological aspect. It is an ecosystem aspect. It's public regulation. Yeah, there's a whole range of things, and that's in many ways why we are out here talking about these things and trying to get people to look at that horizon and start to make sense of it. We talk to a lot of blindness organizations today who at best, maybe serve 20 people a week, on orientation and mobility. They need to service 2,000 people a week. Like it's just, And so we recently brought in orientation and mobility, our head of orientation and mobility into the company to really start to understand how can orientation and mobility training scale using these kind of devices. How can one trainer work with, instead of 2 people a day, which is pretty much the limit that they can do today, to 10 people a day? Can you set up the device and I'll just give you an example. Today, for someone to be able to walk from their home to the nearest Starbucks, they have to go through the whole orientation training, which can take months, if not years, before they can do that initial walk independently. But if you could train them to use Glide before you taught them orientation even, and trained Glide on that route, and Glide can walk them, literally hold their hand and walk them to the Starbucks and back, you immediately lowered the mobility barrier, And they can start to develop the skills and experience the real world and the nuance of that from day one. And what does that mean to the process of orientation and mobility training? What does it mean if the orientation mobility trainer can dial in from a distance and look for the Glide camera and actually help the person deal with situations without having to travel there and unblock issues? These are all hypotheses. We haven't done any of these things. That's the kind of things. In many ways, initially, these devices are going to be used by people who have pretty established orientation and mobility skills, and that's actually the benefit. Because the agent that I talked about doesn't need to be perfect early on. It wouldn't be able to be perfect because it hasn't had enough experience. But it's connected to an intelligent individual. Blind people are great problem solvers. They quickly understand their situation and figure out how to get out of a situation. And as we get more data and improve the features, enable it to connect to maps and guide. So the goal here is, how do you move from people who are already established orientation and mobility skills to people who don't have them, people who have much less capability. And that's really, so there is an aspect of the capability of the technology to do that. There's the aspect of how these people get trained, supported. Are they supported by the organizations of today? Are they going to be supported by an organization of the future? Are they going to be supported by other agents, maybe? Are they going to be supported by peers? There's a whole range of ways to think about how that scales. And then, of course, how cities and transportation organizations start to make these kind of, enable these kind of agents to operate and connect into the systems and information systems that are, so that when I arrive in a train station, I can get to the right train, or I arrive on my Waymo vehicle. You can start to see the interconnects between these different technologies. Do you want to add something, Kyle?
Yeah, I would just add, I think from a technology standpoint, things are moving so fast. Like the things that we've described exist. We can refine them. The technology, the physical product, we can process and have the agent live on edge on the device with an all-day battery life, right? So that's not as huge of a hurdle. I think what's been a hurdle in the past that we're trying to address here is the accessibility of this technology. Like Amos mentioned, right? The expectation is that a device like this is going to cost $10,000 because people can charge that because it's going to go through insurance, which means that a very slim portion of people are actually going to be able to get access to it. We said, forget that. Let's price it like a cell phone. Let's build it from the ground up with a BOM that works with that price point.
BOM is bill of materials.
Sorry, I forget sometimes. Thank you. Yes.
Kyle is my hardware guy. So.
I like hardware. Lots of acronyms. Point being, right? Like we're flipping the model. We're making this cost like a cell phone. $1,499 for the device, $30 a month. We're not going through insurance. We'll get there eventually. But we want to launch the business such that anybody could afford to buy this on Amazon, offer a payment plan, get this in their hands, get it out there, collecting data, adding value, transforming lives. Let's get this going. Let's not price it out of reach, right?
Matthew Widener, King County Metro. Again, thank you so much for this wonderful talk. Very inspiring. One of the things you mentioned, public transit and how public transit and delivers how public transit agencies, should expect to deliver better information to our customers for these kind of agentic systems. One of the struggles that we have is we're always building against yesterday's innovations, not tomorrow's innovations, whenever we are going out and procuring or building new systems. So could you talk a little bit about how we should change our approach, or how we might change our approach to better support these types of agentic systems, and what things these systems might look for in both the spaces and in a digital realm?
What a great question. And in many ways, when Anat asked me to come and talk, that's what I was struggling with. I was trying to think, how do we move all of our view of and the horizon that we are looking at, and start to think of what we are doing today, what we've been doing in the past few years, in the context of where we are going. Yeah? And the context in which we are going, it's not going to be apps. It's not going to be the kind of systems that we look at today to help us navigate around. It's going to go through that that intelligence layer. And if we start to think how we think about our work like I said in the talk, to support those agents, we might think about things in a slightly different way. I'm not saying that we will. Like, I'm not the expert in what you do at all. But I urge you to start thinking about it in exactly in the way that you asked the question, to start thinking about it in that context of how do you present that information in a way that not only does it show up on an app or a website, but it's easy for an agent to get hold of and produce reliable, verifiable information to people in a way that is easiest for them to consume, that in a way that's easiest for them to actually go through the experience you're trying to create. So I'm not avoiding a question. I'm reinforcing the question. There are ways, every big and small AI companies are working. There's embeddings and indexes, context. There is a whole platform. I'm going to mess up the acronym. MPCs, PCMs, what are they called? Basically, it's an API, an architecture that enables agents, like a consistent architecture that enables agents to pull on enterprise data and enterprise information systems. MCP, thank you. I knew I was going to mess up the acronym. But it's an emerging API, right? It's not, nobody's going to say that that's going to exist next year. I mean, this world is moving so fast. So I think the important thing is to start really considering, start small, start with the things that are coming to life. It's very easy to put together an agent today. Try to think how you're going to structure some of the work that you do to contribute to that agent. How can the agent contribute to what you're doing? And again, I don't have a specific answer to your question, but that's what we have to work on. That's where we are in a university.
So we have time for two more, if we're fast. One here, and then Jeff will be the last one.
I'll be fast. My name is Chelsea Nelson. I work at HopeLink, Find a Ride, and I will preface saying I am newer to the transportation space. You've just created a super fan, very inspired by the work. And the thing that I'm curious about, two questions. One, is there a ground zero for this product and for this technology? Is that Washington State? Is it somewhere else? And all of us work in different spaces with local, state, federal government. What kind of lobbies exist to help clear space to get this out in the appropriate governments? And what can we do to help do that if Washington State is part of Ground Zero?
So Ground Zero is Jackson Street in Seattle. This is where our lab is at. This is where we are working and developing these technologies. So we actually use the sort of square mile around our lab as our test ground for a lot of our work right now. We do have about 750 pioneers, we call them. These are people who have already purchased the device, and we're going to be rolling those out this year. They are across the US, Canada, and the UK, so Ground 0.1 is a much wider space. And Glide is designed, like I said, from the ground up, not to be bound to a specific locale. But it will do better and will be supported better, and people will have a better experience when there is better support in the infrastructure and in the environment. Yeah, and so I would love to continue that conversation with Washington State. The work that Anat and her team has done to map the whole state, map the sidewalks, map and understand and be able to develop routes, I think it provides us a huge opportunity to really be ground zero for a lot of these ideas, and I would love to continue this conversation.
You can talk into it.
Hi.
Jeff.
I'm Jeff Abrams. I'm blind. I have a guide dog. I'm an ex-Microsoftie. This is more of a technical question. As a guide dog user, you know about intelligent disobedience, where a dog will not have you do something that will get you in danger. How is Glide going to deal with something like that?
So Glide is, as Ellie, our head of R&M, actually emphasized to us yesterday, Glide is all the time doing intelligent disobedience. In the sense that, so if you walk along with Glide along a corridor and you click the button to turn left, but the wall is there, it's not going to turn you into the wall. It's going to continue straight and look for a place to turn left. And only once that space clears up, you can turn left. If you are standing on one side of a, let's say, the entrance to a hotel, and you can hear where the reception desk is, and you point Glide in that direction and start walking, it's going to get all around the obstacles and look for a path to guide you in the direction that you were going. So it's all the time interacting with the environment and disobeying you, where it's sensible to do so. And I think the one place that I would be cautious to say much more about is road crossings, where we train the dog to be very wary about a car coming and push us back, or not accept the forward command if there is a car coming, I'm not going to say to you right now that Glide will do the same for you. I would say that it's entirely your decision when to cross the road. Glide will put the brakes on. There's brakes in the wheels when you get to the edge of the curb, and when you want to move into the road, you'll have to physically release the brakes, so press the button to release the brakes, and then Glide will get you across the road in a straight line as quickly as possible with actually flashing hazard lights in the handle to make you super visible as well. But it will only really push back if there is a physical obstacle in front of it. It's not going to look for cars and anticipate them, at least not at this stage, perhaps later on, but I wouldn't jump that far. Okay? Jeff, thank you very much, and we'll be compliant to Sai there, and we'll express our gratitude. Thank you.
I'm sorry, do you have time for one more? We have a question from online, the remote attendees, and we just want to give them a chance for one more, and then we'll go to break after that.
Okay.
Okay.
Online.
Thank you.
Hi, Amos. Thanks again for being here today. We have two questions, and I will leave it to you how to take them, or if you want to take both or just one. Pradeep's question is, can reinforcement learning be used for the middle layer, basically taking the reward system from the user to the system? And Phoebe Smith asks if Glide can use GTFS pathways data.
So reinforcement learning is part of the learning for the middle layer, as well as self-learning. Basically, a lot of the data that Glide is able to collect is very detailed. Like, we have two cameras in the device, and Kyle can show you. One is looking forward, one is looking down. They are depth cameras, so 3D cameras, so that they collect very rich information about the space and every nook and cranny and drop-off. But we also collect the movement data, so the sensors, the odometry, the IMU, everything else. And that allows us to build a model that can predict what will happen if I did something. And so there is self-learning and reinforcement learning in the environment. We have, to the other question about do we connect to data, so at present, we have not connected to specific data sources. We basically go through the Google Maps API for things. But that's where I see the opportunity for Glide to actually start to, as the agent, to start to pull on other information. And I just, again, I think it's hard to believe until you see it, but like, if I get a route from Google Maps, I get the JSON back from Google Maps with the, I don't know, 20 steps that you need to take from your place to a nearby cafe. You can ask the agent, okay, tell me about this route in a summary. And it will literally summarize everything and tell you, okay, you're going to walk north on Jackson Street, take a left, and then you'll turn right 200 meters later, and it will come up on your left. I mean, that is unbelievable. What the kind of the nuance that you can get and the interaction that you can have with the data. And that's what I hope that we can all build and enable these agents to help us as people with disabilities to interact with the data in a way that's going to help us to make decisions, help us remain agents, keep our agency, and be in control of the situation, and yeah, bring everybody out. So thank you very much. I think we'll have to close here. Thank you.